Recording. Okay, so welcome to the distributed tracing world and Hypertrace as an open source tool for it. We have now a webinar where we'll touch upon the basic things around observability and Hypertrace as a tool, and then we'll talk about compliance. And with me here, I have Pavol Loffay and Tessa Viitanen, and also by phone, straight from America or somewhere long distance. Anyways, Dave Nielsen, who is community manager of Hypertrace community. And do you want to say something, Dave, for our audience?
Yeah, I'd like to say top of the morning to you. It's very early here in California. And just a couple of words. I want to thank you for having us on your program here. And for those of you who are joining, I hope you will join us in our Hypertrace Slack group. You can join that by going to hypertrace.org. And if you then click on the Slack link or the Join Us link, you'll get an invitation to join us on Slack, where we answer questions and have discussions about Hypertrace and distributed tracing. Other than that, I hope you'll come check out our documentation as well. There's some great download documentation there to get started with Hypertrace and learn more about distributed tracing. Other than that, I look forward to your program.
Thanks, Dave. And this leads me to remind you also that in case you ever need anything around Hypertrace or observability or, well, a lot of things around distributed systems in terms of webinars or training or consulting, we are all available for that. And my name is Marjukka and I'm Osaango, and I will shut up right now and leave the floor to Pavol. And while Pavol is starting up his presentation, I would like all of you to put into the chat if you know anything about observability or not yet, so we can get to know you a little bit better. But hey, Pavol, take it away.
Okay, thank you. So I will do some introduction to distributed tracing and Hypertrace. And we will start with some explanation and discussion about understanding deep systems, because deep systems is actually the core of the problem why we will talk about distributed tracing. So before we start, I would like to talk about myself. I'm Pavol Loffay. I work as a software engineer at Traceable.ai. I work on the data collection and Hypertrace project. By data collection, I mean libraries or agents that you can use in your applications to instrument them and then send data to the Hypertrace platform. Before Traceable, I was roughly 5 years at Red Hat, where I was maintaining and working on CNCF Jaeger and Open Tracing projects. And I was also contributing to OpenTelemetry, to the collector, but also to Java SDK. And you can follow me on Twitter at @Loffay. So onto the agenda, again, there is, I will talk about these deep systems and how it's important to use distributed tracing in deep systems. And then we will have a look how we traditionally monitor our systems with telemetry data and what distributed tracing adds to the monitoring world. And last but not least, we will together instrument a Spring Boot application with OpenTelemetry Java agent and monitor its APIs in Hypertrace. So deep systems, nowadays, when we are developing applications, these applications are incredibly complex. And so usually when you are loading a simple application, for example, a Facebook application or your Gmail, what happens behind the scenes is that the request that loads that application goes through, maybe dozens or even hundreds of microservices somewhere in the cloud. And it's very difficult to understand what happens with the request end to end. So this is a screenshot from Jaeger, and it shows Uber architecture, and each node represents a service. And so, for example, when you are ordering a ride into Uber app, what happens is that a request, it enters the ecosystem and it goes to the first service, then it goes to the second service, and so on. And it can, go like this it can touch, 20, 30 services. And what's important here is the depth of the call graph. Here we see maybe 5 lines, so it goes maybe, it's not 5, it's 1, 2, 3, 5, 6, 7, 8 services in a row are involved to process the request. And it's very difficult to understand what happens when there is, for example, an exception in one of these services. So if we want to truly understand and debug and find a root cause of the problem, we have to understand what happens in the downstream service, but also in the upstream service. We have to have the end-to-end view with the request. And so these are, again, like screenshots from very complex systems. So on the left, there is Amazon.com, on the right, there is Netflix, and we see there are maybe thousands of services. And it's almost impossible to, to tell the story about the system, what is happening inside, if we don't know what is happening end to end with each individual transaction. And you may say, okay, but these systems, there are thousands of services, but in my environment, I have maybe only 20 or 30 services. It doesn't matter, because the same errors or the same, weird behaviors happen in very smaller environments. And even though you have 20 services, if those 20 services are called in serial, it's very hard to understand what is happening. So we traditionally used to monitor the systems by using metrics and logs. And metrics, they are great. They provide kind of immediate understanding what is happening in your system. You can see almost in a real time if there are error spikes or if the response time is increasing. And you can also set up alerting using metrics. But there is one downside. There is no context in a metric. So usually when you see a spike in a metric, what you do is you go to logs to find out what is happening in your system, because in the metrics, there is no context information. You cannot debug your systems by using metrics. So on the other hand, logs, they provide a lot of context, but maybe there is too much context. Oftentimes, application, they log a lot of information. And there are a couple of problems with logs. So first of all, there is no standard semantics of what an application should be emitting as a log. So when you have a polyglot system, your Golang application might be emitting totally different information than your Java service or your Node.js service. So this is the first problem. There is no standardization on the data what is emitting by log instrumentations. The other problem is that, so here we see logs from a single service and from a single request, but usually your service is serving multiple concurrent requests, right? And these requests, as your service is processing these requests, it's emitting logs, and these logs are mixed together. So you cannot really tell, what log belongs to what, to which request. And when we talk about distributed systems, it's even much complicated, because then you have multiple services involved in this transaction, and it's very hard to correlate logs from multiple services. It's hard to correlate the logs from single service, even harder from multiple services. So the solution to this problem is actually it's called context propagation, but I will talk about context propagation later, which is a foundation of distributed tracing. So what I want to highlight here is that your monitoring system should tell a story about each individual transaction that is happening in your system end to end. And to be able to tell the story, you have to propagate the context as your request or transaction goes through services. Only then you are able to really tell what is happening. So what we want to achieve basically in distributed systems when we monitor them is to have kind of like distributed stack trace. And one last thing that I want to mention here is that, traditionally we used to monitor our systems by just, collecting data like logs and metrics. And this is not enough in the modern applications, because now the monitoring system should be able to answer very complex questions about these transactions. And to answer these questions, you should have all the information from all the services that were involved in this transaction. So this brings us to solution of how we should monitor distributed systems, which is distributed tracing. And I will talk about concepts here, which is a span, trace, and distributed context. So on this slide, we see two diagrams. On the top part, there is a user that is creating a request to a distributed application running somewhere in the cloud. And on the bottom, there is some diagram showing a trace, how a trace may look like from this invocation. So when a user creates a request and the request enters cloud, then a load balancer, then a first microservice, what happens or what tracing integration does in the system, it creates a span for each invocation in each service. So for example, in a first service, let's call it service A, a tracing system creates a parent span or a root span. And then, the business logic, for example, is invoked in this microservice, and it creates another operations. So tracing creates another span that represents this invocation. Then microservice calls a second microservice. What happens is that span context is serialized into the network. In this case, it can be HTTP headers and is sent to the next microservice. And that next microservice does the very similar job as the previous microservice. It just creates a span for the invocation in that microservice. And what is important here is, as we are creating these spans, we know who is the parent and who is the child. So later, when the request finishes, the tracing system can collect all these events and can correlate them together and show you the full picture of what happened, in each individual microservice. So span is basically a data structure that has a start time and the end time, and then has a bunch of metadata associated to it. So for example, there are tags which can be, for example, database instance, database statement, so very rich information. Then there are logs that are very similar to tags. The only difference is that logs are timed information. Log is any basically message, but also when it happened. And the span context is also associated with each span, and it carries some identifiers. It carries the trace ID, which is a unique identifier for the whole transaction. Then there is a span ID, which is unique for a single span, and then some key value map that is propagated through your architecture. So I will go back. When a request hits the first microservice, the tracing creates a span, but also creates this unique identifier called trace ID. that is propagated to all the microservices. And then the services, they can use the tracing API to create these baggage items. And these baggage items are also propagated through microservices. And this is a very powerful feature, not very well known. But for example, you can propagate username or user ID from your front-end microservice, which is the first one, down to your database layer, and then do, for example, resource attribution based on the user ID. And it's very powerful because you don't have to change the API in all of those services that live in the middle. Because otherwise, if without the baggage, if you wanted to propagate something through your services, you would have to change, the public APIs of all of those microservices. But baggage is a concept. It's a very powerful concept. Maybe we can talk about it in a separate talk. There are a lot of use cases for baggage where it can help. Okay, so we talk about the span. Span is basically represents an invocation in your system. So it can represent HTTP invocation in your backend service or invocation of a business method. And a trace is basically just a collection of spans. It's something like a graph. We'll see that in a Hypertrace UI. And then distributed context is just a context that is associated with each span, and it's propagated through all your services as a request goes. So before we go to demo, I would like to talk about Hypertrace. So Hypertrace is an open source distributed tracing system, but also observability platform. It's much more than just pure distributed tracing system as we know it from other open source tools like Zipkin and Jaeger. So Hypertrace is meant for application developers, but also for deployment teams. You can see, or you can test out your Canary or AB deployments, but also, you can use it as a site reliability engineering teams. And Hypertrace can accept or accepts telemetry data from all major open source tracing libraries. So there is support for consuming OpenTelemetry, Jaeger, Zipkin, or Open Census formats. So if you are using any of these, you can start using Hypertrace without any change your basically tracing instrumentations. So now I will jump into demo. So what I would like to show you here is how you can instrument a Spring Boot application with Hypertrace Java agent. So what I have done, I have just created a Spring Boot application by using this Spring initializer, and I just chose the Spring Web package, and then I hit the generate button. It downloads the zip with the application, and then you can unzip it and run it. So I go to terminal and I will start Hypertrace. Actually, before starting, start Hypertrace is very simple. You can go to our documentation, hypertrace.org, or to our GitHub organization. And in the Hypertrace repo, you see all the instructions how you can run Hypertrace. It runs on a Docker via Docker Compose because it consists of multiple services. Or it runs on any basically Kubernetes distribution. So when you compare this deployment to other tracing systems like Jaeger and Zipkin, it might sound that it requires a lot of resources and a lot of services to run. So by default, Hypertrace uses Kafka, MongoDB, and some Java services that collect and process data. When you are starting, on the other hand, when you are starting with Jaeger and Zipkin, you can run them as a single service. And The difference is that Hypertrace has been designed from very beginning as a very scalable system that can process a lot of data. So it requires, scalable architecture. And Zipkin and Jaeger, you can really start them with in a demo mode where they use just in-memory storage for demo purposes. But once you want to scale out Jaeger and Zipkin, you will have to eventually use Kafka and scalable storage to handle all the load. So you will end up in a very similar, deployment model as Hypertrace. So okay, I will start the Hypertrace. It's very simple, just Docker compose up. It takes usually around 10 seconds to load all the services. And then, so in the application that I created in the Spring initializer, it's very simple. We can see in the POM file, there is just Spring Boot web starter, and I just have added this OpenTelemetry API, but I will talk about it in a minute. So there is the application, there is the main class, and one web resource that defines two APIs. The first one is on the root endpoint, which just returns a hello message. And then the second API, it's called call itself. What it does, it just creates a REST template, which is like HTTP client, and it uses that client to call the root endpoint, and then it returns the result. So to instrument this application with Hypertrace, it's very simple. You just go to Hypertrace Java agent and you download the distribution, which is on the release page. So this is a standard Java agent that is it's built on top of OpenTelemetry. So it supports all the OpenTelemetry features and frameworks. But in Hypertrace, we're adding more functionality to this agent. So we are collecting more data from the environment. So for instance, our agent, in addition to OpenTelemetry features, it can also collect request headers and bodies, but also response headers and bodies. And also you can use, you can implement a filter that receives all the information at the request start. And so where in the filter, you can implement a filter that calculates, for example, interesting statistics based on the headers or bodies that you are receiving. Okay, but that's again, like we can have a separate talk on this. So what I will do, I have downloaded the agent, which is here in the same directory as my application, and I will just run it. To run the agent, Java agent, you just run Java agent, and then you provide a path to the Java agent, and then a classic. You execute your application, your Java application with a jar command, Java this jar and a path to your application. I have already compiled the application, so I can just run it from my target directory. So let's see what happens. So we see there are some logs from the agent, and then once the agent is loaded, the application starts. So now, when I create a request, I should see some telemetry data coming to Hypertrace from this application. So I will jump to web browser and I will create some requests on the application, and we see that application is returning a hello from the root endpoint. And if I execute the call itself, it will return the got hello. It's very simple API. I will just invoke it a couple of times. So let's go to Hypertrace UI. So in the first screen, we see like the macro view on the system where we get, high-level statistics, what is happening in the system. So we see, for example, information like P99 latency, number of calls, error count, and then the top APIs or the endpoints from the application that we are monitoring. Then we can drill down into services where we see all the services that we monitor. In this case, there is obviously only a single service called Spring Boot Demo. If I zoom in, I again get some overview of how this service is behaving. I see some latency information, error counts, and calls. And I also see, the dependency diagram for the endpoints. And if I go to Traces tab, I see, each transaction or request that went through this service. So for example, if I pick this one, I see the fragment of a trace for this API. I can go to full trace that shows the full transaction. And here we see, the first we invoke the call itself endpoint, then the call itself invoke the root endpoint. If I want to know more information about this location, I can click on these on the lines, and I will see a bunch of contextualized information. So I see, what kind of HTTP method it was, and I see also all the request headers and also request body, which is, Hypertrace specific functionality. Is not the OpenTelemetry functionality. Is the functionality what we are adding in our Hypertrace agents. So this screen is great when you want to troubleshoot your transactions because you can see the timing information for each operation. So for example, this first operation took 10 milliseconds, and then some operations were took less time. So we see, for example, the root endpoint invocation took only 3 milliseconds, but the call itself endpoint took 10 milliseconds. So for example, like creating of HTTP client, what I did here, it might take, some couple of milliseconds to create that. So all right, so we have seen that, instrument Java application with Java agent is super simple. You don't have to change your application code. You can just, provide the Java agent argument when you are starting the application, and the agent instruments the application automatically. However, if we want to, change the telemetry data that the agent is emitting, we can use OpenTelemetry API inside your application. So here, for example, I can call span.current, which will return the current span for this operation. And I can attach some attributes to it. So for example, I will attach hey here. And now I have to recompile the application. And once we, again, deploy it with the Java agent, we will see this attribute in the monitoring data. So by doing this, you can change you can attach more data to your to the spans the agent is emitting, but you can also create new spans for example, for your business logic.
Thanks, Pavol. Do you still have any quick last points to add, or was this?
Yes, this is. I will be finishing in a couple of minutes. Yeah, I know I'm running late. So last functionality that is in the Hypertrace is this Explorer, which is very similar to Jaeger or Zipkin explore trace view, where you can query all the data that is sent from your instrumentation. So for example, now if I run the tags, I can query the telemetry data by the tag that I added in my that I just added in the application. So I think the key was hey, and then I specified the value with the contains key value. I think it was hello. Oh, let me see here. It was here. Let me try it again. Yeah, so we see we can query data by basically uh, any attribute that is present in a spans. It can be, for example, HTTP URL or HTTP method, or even database query. So just to summarize, Hypertrace is much more than a simple distributed tracing system. It provides also some dashboarding, topology view that is automatically derived from the data that is collected by Hypertrace. It's highly extensible. So for example, if you want to add new functionality, it should be simple to do. And also it's compatible with all the major open source tracing formats. So if you're already using OpenTelemetry, Zipkin, Jaeger, or Open Sensors, you can start using Hypertrace right away. So thank you for your attention, and if you have any more questions, feel free to visit our Slack channel. The link you can find on the hypertrace.org, or you can go to our GitHub organization, github.com/hypertrace. All the source code is there, and you can find the documentation how to deploy and start using Hypertrace.
Thanks, Pavol. That was a great introduction to observability and Hypertrace. If somebody has any quick questions, we can take maybe one. Otherwise, we'll move over to Tessa's presentation on the compliance issues related to distributed systems and data and how Hypertrace can help to solve those. Are you ready, Tessa?
Yeah, thank you. So welcome everyone. My name is Tessa Viitanen and I'm founder and CEO of Techie Stories Ltd. And you can follow the company at Techie Stories_stories and at T3554V. It's basically in each and every social media account. So what I'm going to talk about is about why API tracing is essential in your ecosystem. And I also will cover some of the information that you need to have from your system in order to be compliant with different type of frameworks. Because when you have mass of data, you also need to have some type of method to actually trace the compliance audit trail within the systems. So what we are also going to talk about is how you can learn added value proposition, to create added value proposition for your API customers, because it's really important that you can actually provide them service levels and service level agreements, which are pretty common in networking space, but now it's also a possibility in API world as well. You need to know the data you are processing, and you need to be able to design the services you are providing using APIs. So one of the key questions is usually, what about the privacy? For instance, there was issues with Facebook sharing data for analytics services and such. And as it was fairly new, I believe that one of the key points was that this information and consent requirements were not that clear at that point. And always when you do things as a pioneer, things and this and that happens, but there is a way to avoid those mistakes. So basically what you can do is that you verify that you have the consent requirements in place, you have information types using tags or such, and you have the data classification using tags or such. And then of course you need to design your security requirements as well when you are working with your API ecosystem. So if you think about what is really important in regarding privacy and whatever you do with your data when it comes to subject data subjects, people who are actually using the services, people who are providing their information, their private information within the services. There can be different level of information, personal identifiable information, financial information and such. So what is really important that you follow the CRUD, which is create, read, update, and delete. And if you think about CRUD, so basically create is like you put something there, get is read, then you have actual update process where you have the method of get or put, and then you have the delete requests as well. So you need to follow all of these trails in order to be compliant. And this is really, really important to remember that this is the key success. It doesn't need to be that complex. You need to know how you process the data and the legality in different countries where you are processing the data. So it doesn't matter whether you have this kind of huge distributed systems. The most important thing is that you actually have everything in place, you have the tags in place, and you have the classification of the data as well. Because when you have the tags in place, you know how to secure that data. You can also consider anonymization, pseudonymization, but still, even though you have those, you still need the CRUD when you do any transactions which contains any of the private information or sensible information. And when you think about security, so you need to provide confidentiality, integrity, and availability. For confidentiality and integrity part, we don't go that deep into this session, but we are actually going to talk about a bit about availability, because that is fairly important. So what is availability within this kind of distributed systems and with APIs? So one of the key things is that when you think about availability, it's part of the EU GDPR and other privacy frameworks as well. So you need to know what type of information you are handling. So you can use tags to name this information like private identifiable information, sensitive health information, credit card information, And then you need to figure out whether you are combining information, because when you are combining information, then you always, even though it wouldn't be privately identifiable information at first, it could become one. So every time researchers want to gather mass of data, which Hypertrace is good for as well. So basically, you need to know what type of information you are combining to see whether it becomes the sensitive health information or highly risk for the data subject. So that's really important to understand. So why data protection matters? Here is a couple of frameworks that I have taken here, because there is some of the key things that are fairly common with all of these frameworks, all of these regulations. So GDPR is EU General Data Protection Regulation, where you need to be able to provide information how you process data, and that you are doing it in legal ways and you secure it legal ways. In Japan, there is API, which is an act of the protection of personal information as well. So you need to be able to do that in that country as well. So basically, you can also use tags for geolocation and such. Then we have Canada, which has PIPEDA, which is the Personal Information Protection and Electronic Documents Act. So there you have the same thing. So, and in US, you have Privacy Act and CCPA, HIPAA, COPPA, GLBA. So there is multiple laws that you need to comply with. And if you use tags and such, it's much more easier. In Switzerland, you have Federal Act on Data Protection. So basically, it's compatible with the GDPR, as is Japanese as well, and PIPEDA. So when we go to availability, so before you can even think about service level agreements together with customers, you need to know the service level indicators, and it's quantifies the quality and reliability of your APIs. So if you have really poorly functional API and it doesn't provide latencies and such measures with your added value proposition, with your service level that you promise to customers, so your customer expectation will be poor and they probably stop using your APIs. So this is really important, that you need to have the service level indicators at work first, the metrics, and then you need to have the service level objective. It can be 99.95, for instance, if you have some type of premium service, and then you can have 95%, where you have a little bit lower promise for the service. So you can actually build service levels for your customers. And of course, when you are dealing with test environments and development environments, so basically in test environments, you probably will have lower SLAs, but when you are developing, it's really, really frustrating for developers if your API is really, really high in latency. So why we need the service level objective when you are providing the SLAs? It's the key figure for any contract to come. So you need to have the level of service what you want to promise to your customers. So never promise something over when it comes to APIs, because most of the users of APIs are developers, and that will just provide bad and poor developer experience if you don't have what you promised they are testing the API latencies and such. They know the technology, so you really need to be realistic on what you can offer and how you offer it and where from. So if you think about what is the difference between these aggregations that you can see in Hypertrace, so there is P50, P95, and P99, and these are collected and calculated from the raw data across all APIs that you have within your distributed systems. So 50% percentile latency is the worst latency that can be observed by 50% of all requests. So basically, this is something that you might consider for testing only for what you want to provide for the first test on the APIs, and you tell that it's not, it might have higher latency due to the fact that it's free and it's for testing. But then when you go to 95% latency, then you actually already are much more higher within your service and higher quality. And of course, 99% it's usually a production environment. Usually it's might be better if you have developers as buyers to provide better experience to actually raise the development part as well to 99.9% or such. So how you can see that in Hypertrace, you can actually see in each of the services that what type of service you are offering. So here is one of the explanation on what is your latency within P99. So this is pretty good. And when you follow your service levels and your service level objectives, so you can actually see whether you would get sanctions if you have service level agreement with the customer, and you should be able to see and provide them all the monitoring data, whether you have breached the SLA contract. So this is really important that you have all the data and you can provide the report for your clients to introduce them that, okay, we have been in this month, we have been able to provide you the SLA that you have requested, for instance. So this is really important when you are building the contracting service level agreements, because they are contract and they are usually binding. So you might have sanctions on those as well. So you probably want to consider what is your lowest latency and what you promise to the customer. So with Hypertrace, you can actually do that. Then, of course, application flow is really important to see what type of services you have, because each and every one of the application flows, you can actually see the services and see and dig deeper into the services and see what type of service level each service is providing. So you can actually see that, okay, if you want to provide, for instance, product catalog services and such, if you want to provide lower latency, lower service level agreement on that service, then you can also consider where the services are running in and what are the priorities on those services. So let's see what's the time is. It's 5:02. So basically I'm not showing demo, but because we have only 5 minutes and I would like to have some questions as well. So
yeah, I think that we probably do not seem to have a lot of questions, but if anybody has any questions, then feel free. But if you want to do the demo in 5 minutes, then go ahead, or we'll just kind of start chewing up this very heavy set of presentations that you guys gave us today. I mean, there is a lot of like, my head is going around in circles, but it was really good stuff, because I think that some of the stuff, like for example, SLAs, the compliance, the kind of the idea of like, what is the data, who should see the data, what is the kind of availability of the APIs, and all of that it's very hard to start tracking it and make sense out of it when you start having a lot of APIs and a lot of data flowing around in a distributed system. And I think that you kind of gave us a really good insight on what's happening and how you could do that, and what are the compliance requirements that you should consider. So together with Pavol's presentation of like how easy it is to set up, at least if you know Java, but I'm suspecting that with all other programming environments too. So you can do all of this from a business point of view that you presented, and it's pretty easy, as Pavol demonstrated. But I think that it's best if we just actually wrap it up right now. Don't see any questions coming up, but I think that this is a good start. And both of you, Pavol and Tessa, you pointed out that there's such a lot of stuff to still learn about this area. So I'm sure that we have a lot of other topics to talk about, and be sure to contact either Tessa or Pavol with any questions, or Hypertrace, and join the Slack channel in Hypertrace to know more. And about the APIs, you can always visit Osaango Academy to learn more on APIs and APIs as a business. Thank you, everybody. Any last words, Pavol, from you? Anything that you want to add?
Yeah, so we are just starting with Hypertrace, and if you have if you would like to try it out or talk to maintainers, or just have some questions about distributed tracing, feel free to reach out to us on our Slack channel. We are very keen on talking to you and help you with anything observability related.
Yeah.
Yeah, I think Tessa has experienced that firsthand, setting up the environment, so we can vouch for the helpfulness. So thank you, everybody, and see you some other time in some other point of observability. Thank you. Bye.
Thank you. Bye-bye.
Bye.